Okay, pre-calc. So we're going to do some more intersections problems with our conic sections. And so they're very similar to what we just did, but we're going to introduce some hyperbolas, and they get a little more complicated when you have hyperbolas. Really, it comes down to when you're graphing. The hyperbolas get really complicated. So you're going to need your straight edge. So the first part is going to be just the same. So we're going to solve our systems of equations and find your x and y. That's no different from what you've done before. So to start, I'm looking at my two equations here. Okay, well, we've got x and y both squared in the first equation, but that extra x involved. So if we try to eliminate x by multiplying by 2 or negative 2 and then adding the 2 together, we'll keep a y squared and an x, so that won't really help us. So what we need to do is we need to eliminate y if we're going to use the elimination method, which I recommend. So let's multiply the top equation by 3 and then add the two equations together. Okay, I'm just going to rewrite the second equation, have everything lined up. And so once you've multiplied through and you can verify, then go ahead and add your two equations together. Now we've got all x's and constants, and from here put everything on one side and factor. Pause, of course, if you need a little bit of time. Okay, so once we have factored, now go ahead and solve. And we get our values for x and for y. Sorry, we get our two values for x, not y yet. Now we need to find our values for y. And so we're going to substitute into one of the original equations. So pick the easier one, probably the second one. And then we'll start substituting in. So I'm going to start with negative 6, just because that's the easier one. I'm going to save the harder one for later. And I'm going to substitute negative 6 in whenever I see an x. And then solve. So go ahead and continue. Maybe go through the whole thing and then, or pause, go through the whole thing, and then come back and check. Don't forget your plus and minus when you're at the point where you have y squared is 16. We should have both positive and negative 4. So our ordered pairs there, the x value is going to be negative 6 for both of them, but you're going to have two separate ordered pairs. So two intersection points from that one x value. Okay, so now we need to also find our y's when x is 12/5. This one's a little bit more complicated. So start the same way, plug in. And then you're going to square. And I even included the 2, so I multiplied through. And so I personally don't want to deal with all these fractions, and so what I do is I'm going to multiply both sides by 25. So now that I've done that, then I get rid of my fractions. They're big numbers, but that's okay. Subtract 288 from both sides. Divide by 75 on both sides. And now, look what we notice. Y squared is negative. I'm not even going to bother to divide because I see y squared is a negative number. If that's the case, no values. Isn't that wonderful? So we're done. We have two intersection points. Okay, so then just like on the last notes, once you have your intersection points, then you need to graph everything and show that those intersection points actually lie on both curves. So let's take a look back at the two original graphs. Our first one, x squared plus y squared, two squared variables, both the same exact coefficient and both positive. This is going to be a circle. So go ahead and rewrite your equation of your circle in graphing form. Double check that you have done your completing this square correctly. I apologize for how tiny it is. And double check your equation of your circle. So you should have a circle centered at -3, 0 with a radius of 5. Okay, next, if you look at the second equation, we have two squared variables again, but this time the signs are different. So it doesn't matter that the coefficient values are different, it's the sign that you're really looking at, positive and negative, so that tells you it's a hyperbola. And so just like before, go ahead and rewrite the equation of the hyperbola in graphing form. On your intersection problems, it's okay to have decimals just in the graphing form, but not in your intersection points. Okay, it's not like the analysis problems where you had to get your simple radicals everywhere. On these, we're just using the equations to actually graph. So, and nothing else. We're not analyzing anything else. So go ahead and use decimals. Okay, so once you have your equation in graphing form, remember you're just dividing by 24 on both sides. And so each one, it's going to be 24 divided by 2, then square rooted to get 3.5, and 24 divided by 3, then square rooted to get 2.8. So now it comes time to do the graph. So for your hyperbola, you're centered at the origin, and it's opening left-right because x is positive, and the vertices are going to be 3.5 roughly out in both directions. We also need to include these points, -6, +4, -6, -4. So for that purpose, I would use, whatever's remaining on your paper, hopefully about half of that part of the page, and I would put your axes sort of in the middle there. Okay, so I'm going to start with the circle, and so our circle has a center at -3, 0, and then a radius of 5, so I'm going to go out 5 in all directions. Okay, once you've mapped it out, then go ahead and draw in the actual circle. Okay, so if you remember on your intersection problems, you are just using the graphs to show that those intersection points are there. So you're not labeling the center, finding the, in the circle case, the horizontal axis and vertical axis and all of that. What we should have done, so I used my shape tool to make a good circle, but what we should have done, we'll backtrack a little bit here, you may have to erase, is we should have drawn in our intersection points. So let's go ahead and plot those, -6, 4, and -6, -4. Okay, so we have those 2 points plotted in, and if you hadn't drawn your circle yet, which we shouldn't have drawn it yet, then what we can do, because we know that, here, I will just move my circle out of the way and I'll put it back in. So looking at the points that we have, we know that circles are symmetric about their horizontal and vertical axes, so around their center lines. And so what we can do is we can use that symmetry to draw more points. So I'm going to reflect this blue point. It's 3 spaces away from that upper point and 1 down. I'm going to go 1 down and 3 spaces now to the right. And I'm going to do the same thing here. I'm going to go 3 spaces over to the right. Okay, so now I have a little bit more, and if you notice that from one point you go 3 over 1 down, we can go from this one and go up 3 and right 1 if you want even more, and do it down here and here and here. So now you have lots of points and you can draw an even better circle. Put mine back in. Okay, so yours should start to mimic mine just a little bit, even though I'm using the graphing tool. So that's your circle, and like I said, using different colors is going to be really, really helpful when you're drawing in hyperbolas. This one, it's just one hyperbola in a circle. The next one, we're going to draw 2 hyperbolas, so you're definitely going to want different colors there. So for your hyperbola, remember, now you are drawing in those asymptotes. So we're going to start from our center. Our center is at 0, 0. And then the slopes of the asymptotes are 2.5 over, or 2.8 over 3.5 and negative. So I'm going to go from here and I'm going to approximate up 2.8 and write 1, 2, 3.5. Okay, and I'm going to map out the 4 points in all directions. So I'm going to go, and I'm going to try to be as symmetric as possible. So this, I went over the 3.5. So now I'm just going to go down 2.8. Okay, and I'm going to do the same thing across. I'm trying to get them to kind of line up in those grids. Now use your straight edge. Don't hand draw your asymptotes on these. Use your straight edge to draw in your asymptotes. And of course, you're drawing these as dashed lines. So when you do this, and I'll get one of mine started, the Smartboard straight edge is not terribly smart. What I do is I take my straight edge tool on paper and I see how I can line it up. So I kind of hold the ruler by the points. And what we want to make sure is we know that this is opening left, right. So our hyperbola has to go around here and go through this blue point. So if when you line up your straight edge through your points, you accidentally go like that, there's no way you can do your left-right hyperbola and not go through the asymptote. So you're keeping that in mind as you're doing this. Okay, so once you are satisfied, you can go ahead and then draw the actual line using your straight edge, and then go ahead and draw the next one as well, keeping that in mind that your asymptote has to go on the outside of this point. It has to go above it. Okay, so once you have your two asymptotes drawn, now we can draw in our vertices, and then we can use our points here for symmetry to draw an even better hyperbola. Okay, so let's start with our vertices. Okay, we're going from the center 0, 0, left and right 3.5, the denominator underneath x, because it's left, right. So about there, and then about there, right? They should line up with those dots that you made for the asymptotes. And so now, in addition to that, I'm also going to plot in these points. Now, we could use -6, 4, and -6, -4, and just reflect them, because we're reflecting our symmetric axis here is right through the center. Our conjugate axis goes right through the origin. If it hadn't, you're going to want to reflect it about the center of the hyperbola rather than the y-axis. In this case, we can reflect about the y-axis. So I'm going to plot in 6, 4, and 6, -4. And if you've done your asymptotes correctly, then they should lie just inside those asymptotes as well. Okay, so then the last thing to do is, now that we have enough points, go ahead and draw in your smooth hyperbola, connecting these 3 points, the vertex, and then the 2 points we just drew, not the points from the actual asymptotes. And of course, you're labeling your intersection points. Okay, so that's our first example. Now let's go ahead and work on the second. So on this one, go ahead and try doing the solving the system part without me. And so pause the video and then come back as needed. You can always fast forward through it if you just want to check your points. Okay, so hopefully you paused. You've done all the work. You're coming back. So you can check your intersection points. Hopefully you got these. And so then if you didn't, go ahead and look through how I go about it. Otherwise, you can fast forward through that. So what I did here is I looked at the two equations, and I saw that I could eliminate my x's right away, and I have this extra y in here, so I didn't want to try to eliminate y anyway. So I eliminated my x's by subtracting the second equation from the top equation. And then we can, what I did to make the factoring easier is I noticed 3, 12, and 63 all have a 3 in there. I divide everything by 3 and simultaneously subtracted the factor, or the constant over to the other side. Now my factoring is easier. If you did it the other way, your factoring would just be harder, and that's no problem. So I did my factoring, and then those are my two y values. Then I picked the easier equation, aka the top one, to plug in each of these y values. So I plugged in -3, I plugged in 7, and very carefully solved through to come up with the x values given that y value. So then be careful. -3 for y is what gave you plus and minus 1. So we only have those 2 points from that y value. 7 is what gave us plus and minus 5. So we have those 2 points. You can't mix and match. We're not going to associate -3 with positive and -5 and vice versa. All right, so now let's take a look at the equations and determine which types of graphs they are. I actually already told you. We have 2 squared variables and different signs, 2 squared variables and different signs. They're both hyperbolas. So now go ahead and write each of the hyperbolas in graphing form. You're going to have to complete the square for the second one, so be extra careful doing that. Definitely pause the video and check back in. Okay, so now that you have graphing form, you have the top hyperbola is an up-down hyperbola centered at the origin, and the second hyperbola is also up-down, but this time it's centered at 0, 1. Okay, so for these, we need to go out to 5 and 7 in multiple directions. So again, you can put your axes in the center of the remaining space, and hopefully you have quite a bit. All right, let's start with the top equation this time. And so it's centered at the origin, and pick a color, but be really careful. Maybe use pencil, and then when you're done, highlight and color, something like that, so then you can tell the difference, because when you have two different sets of asymptotes going through a different center, it gets really complicated. All right, so then our slopes are 2.7, 2.1. So mark in those 4 points. Now, before I draw in the actual asymptotes, I'm going to plot in my intersection points because I know they have to lie on both curves. Okay, so when you have your intersection points plotted in and your points for your asymptotes, then like before, you're going to basically be holding your straight edge. So where I've drawn this asymptote here, you're holding your straight edge there, and you're seeing, since I have this hyperbola that's opening up, down, will I be able to go through these intersection points while it's opening up, down? So they have to be above both of those asymptotes. So before you actually draw it, just verify that it will. And same thing below. Okay, so they both look good, so I would draw in my lines there at that point. So I would wait until I verified. So then, after that, I'm going to use my intersection points, again, for symmetry, to make sure that this hyperbola is the best hyperbola I can draw. So I have these 2 points that are, right now the center of the hyperbola is 0, 0, so it's not a big deal. So we've got 5, 7, and negative 5, 7. So we can go to positive 5, 7 and reflect them downwards. So positive 5, negative 7, and then negative 5, negative 7. And then we can also draw these 2 points and reflect them upward. So this time I'm going to go from the center. So I'm going over 1, down 3, over 1, down 3. So I'm going to go over 1, up 3, and up 3. Okay, and so then in addition to those symmetric points, let's also draw in our vertices, and those are going to be 2.7, so about there and there. Okay, so carefully draw in your hyperbola at this point. Okay, so now that you have your hyperbola drawn in, now we're going to go for the next one. And remember, this one's going to be in a different color, so be very, very careful. Okay, so let's start with our our asymptotes, and we'll plot in those points. Okay, so this time we're centered at 0, 1. So be careful. So from here, we're going up 3.9 and right and left 4.3. So go ahead and draw in those 4 points. Okay, so when you go to draw in your asymptotes, again, we need to include our intersection points inside. So I'm going to start in with this one. And you can see already just how complicated it starts to look because we have many different asymptotes. So let me color code. Okay, that's going to make it a little bit easier. So now I can kind of fine tune this one. It needs to go through the points that I've sort of set up. And again, my hyperbola is going to open up, down, going through these green points. So the green has to be above, that's good. And this green has to be below. Okay, that's good. So now I'm going to draw in my next one. Okay, now that my asymptotes are done, I already have my intersection points. Let me work on my vertices and then my reflections of the intersection so that I have a better idea of what's happening. Okay. So let's see, from this point, the center at 0, 1, I'm going to be going up and down 3.9. So remember, you're not going from the origin. You're going from this point up 3.9 and then down 3.9. Is it going to be above that other vertex or below? Remember, we're going 0.9. The other vertex was 0.7, so we should be a little bit below it. Okay? Try to make mine a little further down. All right, so now we have our vertices, and you can see from here that these two intersection points are at the next integer below and right and left 1. So I'm going to go to this vertex, and I'm going to have these 2 points. I'm using the vertex as my guide point this time for the symmetry. Then from this vertex, to get to my next intersection point, I went up to the next integer and then 1, 2, and then right and left 5. Okay, so I'm going to go to my next integer, that's right here, and then 1, 2 more, and then right and left 5. 1, 2, 3, 4, 5, and the other way. So I'm not going from the origin anymore because my center is shifted. Now I have enough where I can draw in my hyperbola, and of course, then once everything is kind of cleared out, then label your intersection points. And I like to save the labeling for last, especially on a hyperbola like this where everything is so complicated, because I don't know what's going to get in the way. And I don't want to get in the way of an already complicated graph.